So it's time for episode 2 of the Retro KX250 build. This is not my cat, by the way. He just showed up and I'm not kidding about that. But welcome back to the KX250 build. In today's episode, we're going to be tearing down the engine, but I'm going to be doing something a little bit different. Besides just tearing it down and doing a time lapse of it, what I'm going to be doing is taking my time tearing it down and showing you guys what each component of the engine does. Now, we've already got the cylinder and head off this engine. That's how we got it. But I'm going to be breaking into the bottom end and explaining all the transmission parts, shifter parts, clutch parts, everything like that. So if you're curious on that, stick around. This will be the video for you if you want to learn about the inside of an engine. And just to remind you guys, if you're new here, this is a build that I'm letting you guys build. So in the last episode, there was an overwhelming amount of comments about the frame color. So it was kind of decided between purple, white, and green. So what I ended up doing was I put a poll on my Instagram deciding which color the frame would be. And it's time to reveal to you guys that the frame is going to be purple. So keep that in mind. We've got a purple frame Retro KX250 build. Next episode, we'll be building this engine and we're also going to be coating and doing other things. So let me know down below what colors you guys think would be cool for this engine and what we should do. And then once again, top comment wins, and that's what we'll do for the engine. But that's enough yapping for now. Let's go ahead and tear this thing down. So like I said, our top end of our engine is torn apart, but I want to show you guys what the cylinder and cylinder head do. So before I get into tearing down this bottom end, let me walk you through the cylinder and cylinder head. So I'll start my way up and work down. This is the cylinder head. Now this serves multiple purposes. 1, it holds your spark plug. 2, it serves as a top engine mount. 3, it serves as a way that the engine coolant gets into the engine through this nipple here, through these passages. 4, it will seal the system for compression. So this will actually bolt to the top of the cylinder, sealing the cylinder and allowing the engine to have compression. Now this dome in here does have a purpose. What this will actually affect is your compression ratio. So you can get ones that are deeper, shallower, wider, and that will all affect your compression ratio. The cylinder head is a very important part. This surface here has to be perfectly flat, and if it's not, you could have a head gasket issue where you're leaking coolant into your cylinder, washing it out, or you can have a loss of compression. So the cylinder head is very important. One thing you don't want to see as well is a bunch of dips and pits in here. If you have a lot of pits, that could be a sign of pre-detonation, or if you have anything else, that could be a sign of something let loose in the engine. This one, surprisingly, doesn't look that bad. Moving on to the cylinder. Now there's a lot of stuff going on in here, but it serves a couple of purposes. This here is why they call it a cylinder. Now the piston will actually move up and down in here, and the piston has piston rings which seal against this surface. Now this surface has to be nice, even, not out of round, not tapered. It has to be really nice, not gouged up like this one is. The plating on there has to be really in good shape for the compression to be right. There's a couple things on this cylinder, and I won't go super in depth, but I will kind of go over the basics. This here is the reed cage. Now the purpose of reeds is basically a valve. So on a 2-stroke engine, air is coming in, the air goes through the ports in here, will go into the combustion system, and then the piston will compress it, the spark plug will ignite it, and then it'll come out the exhaust. What the reeds do is when the air fuel mixture comes into the engine, the reeds open up, and I'll take these out to show you guys. The reeds will open up, and then once the piston travels upwards, the reeds will seal, sealing the compression off from going back into the carburetor. So the reeds are basically a fancy valve. That's basically what they are. They will seal, and then when air needs to come in, they open, and then when air doesn't need to come in, they close. You guys may have heard of something called a power valve on a 2-stroke, and that is exactly what it sounds like. A power valve is a valve, and it's a little bit hard to see, but I'll put my finger in there so you can see it. So this here is the power valve, and what this does is this is driven off a governor inside the engine. And once the engine gets to a certain RPM, that governor will spin, opening this power valve, and essentially what that does is make the exhaust port bigger. So with the 2-stroke engine, a lot of it is about flow. And you don't want a whole lot of flow at low RPMs. You'll have a lack of power. But once you get in the band, as they say, wide open throttle, 3/4 throttle, half throttle, this power valve will open up accordingly, opening this exhaust port and giving you more flow, which equals more power. And this power valve, they all work differently on different engines. They get fancier and fancier, or they can be pretty simple. This is a pretty simple design. It's mainly just linkages. Now it's time to jump into the engine. I'm just gonna start by taking off the Kickstarter here. Also, just to say, These will often be Loctited, so they may be pretty hard to get off. Now this part here I'm gonna be pulling off is the clutch cover. And this does exactly what it says. Another small little tip, guys, when you're taking apart an engine, keep note of where your bolts go. So you can see all these bolts I have in my right hand are the same length. And then this one here is extra long. So if you want to, you could set your bolts back in the case where they came out of. You can get a piece of cardboard, make a diagram of this cover and put them in there. Okay, so now I'm gonna be pulling off the clutch pressure plate. You see these 5 bolts here? When I take these bolts out, there's actually gonna be a spring in there, and I'll show you that now. There's your bolt and there's your spring. Now these springs serve a very important purpose. What these springs do is they sit inside the inner clutch hub, which I'll show you guys in a minute, and the bolt will go in like this. So when you catch the threads and you torque it down to spec, these springs will have a certain amount of tension on them. And what that does, it puts pressure on this outer pressure plate here. And by putting pressure on that outer pressure plate, what you're doing is essentially clamping the clutch plates together, which makes the clutch spin as one complete assembly. I can't spin this over because the engine's locked up. Okay, so now I'm going to pop that pressure plate off, give you guys a good view of that. You see how there is a lip in there? The springs will actually push against that lip, and that is what's clamping it. It's the spring, not so much the bolt. The bolt obviously is the one putting tension on the spring, but it's actually the spring holding this pressure plate on. Now you can see on this side, there's a really nice smooth surface here. That is what the actual clutch plate right here rides on. You can see the inside of this is grooved. So this will only go in one way, and it'll lock essentially to this inner clutch hub with these grooves. And what that does is it makes a mechanical bond between these two. Now you may be wondering, how does the clutch deactivate when you pull the clutch lever? Well, here's the clutch arm. And what this is here, I'll take it out for an example. This here is your clutch push rod. And you can see it's got a bearing on it. That's so when it's activated, it can spin free. It's essentially a throwout bearing, if you guys are familiar with cars. When you pull the clutch in, your arm, your activator arm, will go this way. And you can see, if you pay attention to this hand here, that is actually pushing that clutch rod out. And what that does, you can see this clutch rod, this clutch bearing will sit right inside this pressure plate. And when you pull the clutch, what that is essentially doing is pushing this pressure plate out. You are relieving tension from this mating surface here where the clutch plates ride. You are also spreading out these clutch plates here. You can see we've got what I call a fiber here, and then a steely is up next. You've got your fiber here, and then you've got your steely. And when these are clamped together real tight, these will not spin. But as soon as you let out pressure, you can see these 2 plates will spin freely. Okay, so I've got the clutch pack completely out, and I wanted to show you guys a couple things on the clutch pack. You'll notice, once again, this is what I call a fiber, and this is a steel. Fiber, steel, fiber, steel. These plates are alternating, and they have to be alternating. One thing you want to take note about the 2 clutch plates is not only the material is different, but you'll notice on the fiber, there's notches on the outside of the clutch disc, and on the steel, there's notches on the inside of the clutch disc. So on the fiber, the outside notches right along the outer clutch basket. And the outer clutch basket is mechanically locked to the crankshaft. So whenever the engine is running, this outer clutch basket will be spinning. And you have your steel with the notches on the inside that lock to the inner clutch hub. So how this whole system works is when the engine is running, this outer clutch basket is always spinning. That is something that you cannot change. This inner clutch hub here is connected to the transmission. So you have this one spinning always, and if you put it in gear with the clutch in, what you will have happen is this outer clutch basket will be spinning, but you've activated the clutch, and now you're separating these plates so they do not have a bind between them. So what that allows is this outer clutch basket to spin while this inner clutch basket is not spinning. And as soon as you let off the clutch lever, what that does is it basically will mate this outer clutch basket to this inner clutch hub. And then you can get power delivered from the crankshaft to the inner clutch hub. And I'll spin this and show you guys real quick. You can see as I only spin this inner clutch hub that our sprocket is moving. So right now I'm in first gear. You'll notice if I go to neutral, you'll notice if I click it into neutral, I could spin this inner clutch hub and it's not moving. But as soon as I put the bike in gear, that's first gear, you could see that sprocket's moving. This inner clutch hub is connected to the transmission, which makes the sprocket turn. I do feel like clutches are a very, very simple thing, but they're kind of weird to comprehend for a lot of people, and I hope that little explanation helped. Okay, get our water pump cover off here. So this here is your water pump cover. What this does is this will bring the water in from the radiators right through this tube here into this water pump housing. And then what you have here is what you call your water pump impeller. And what that does is the fluid comes in and it scoops it. And what that does is create pressure. Now it will create pressure and feed it back out through this here, which will go to your cylinder head or wherever it goes onto your bike. But this basically just acts as a fan would, how it cuts through the air and pumps the air. This just does that with liquid, which is antifreeze in this case. But all it does is the water comes in, it scoops it, shoots out at a pressure through this other fitting here. Now I'm gonna be pulling off what they call the inner clutch cover. When you're pulling apart an engine, besides doing this bolt, this bolt, this bolt, a good thing to do when loosening and tightening is way more important, but loosening as well, is start here. And then besides going to the next bolt over, work down in a diagonal like this, loosen that bolt, then shoot back up to this bolt, down again, alternating each time. And what this effectively does is it relieves pressure off this case evenly. So if you just come around and loosen all these bolts first, you'll have a lot of clamping force on this side of the engine, and then this side's loose. What that can actually do is deform the case, and then when you go to put it back on, you'll have it leak. So it's always good to alternate when you're loosening things, just so you don't end up warping anything. Go ahead and just gently take that guy off. Okay, before I get into the cool stuff in here, I want to show you guys a couple things. So here, this gear and shaft here is the water pump gear. This is driven by the crankshaft, and I will show you guys that in a minute. And this here, this weird looking mechanism, is the power valve governor. So what this does is this will spin by the crankshaft, and there's actually an arm in here, which is right here. You can see that whole thing moves. And what this does is, as this spins faster, there's a weight in here, with centrifugal force, this will move back and forth. And what that does is it pushes on this little plate here. I'm dropping bolts. It pushes on this little plate here, and that actually moves the arm. You can also get a better view of our outer clutch basket and our inner clutch basket. So before I go ahead and start tearing this down, I just want to give you guys a walkthrough of what you can see here when we start to tear this down. So what you have here, once again, this is your outer clutch basket. This here is your inner clutch basket. What you have here is your kickstart gear. Below that is an idler gear right here. You can't really see it, but I'll show you guys that in a minute. Over on this side, you have a couple bearings, which that would be your water pump bearing for your shaft here. And then that's also your power valve actuator governor bearing. What this big sprocket here is, this is an important one. This is the crank gear. So you can see here, this crank gear and this outer clutch basket are mechanically connected via gears. Now this littler one here is actually meant to drive your water pump. I wanted to show you guys one thing on these outer and inner clutch baskets you got to watch out for. So you see here, there is grooving. You always see some grooving on a used clutch basket, but you don't want it to be too much, because what these grooves can actually do is they can get very deep. What that will do is actually bind the plates in those grooves, and that will bind up your clutch. So your clutch will either not work, or it'll get stuck closed or stuck open. And the same thing goes for the inner clutch basket. Right where those steelies ride, you want to make sure that this is not grooved out too bad. On the outer ones, you can file them, but you can only do it so many times. What we've got here, once again, is the kickstart gear. So when this activates, when you kick down the Kickstarter, this will spin. You have your idler gear here. That will be attached to that clutch basket gear. Once again, here you have your crank gear with another gear on it that is driving your water pump and your power valve governor. Down here, we've got what we call the shift star. So I'm gonna go ahead and move the shifter, and you guys can see what happens here. So pushing down to go into first gear, going into first gear, you can see this arm's gonna move down, and it's gonna rotate this shift star back. So you see, that's first gear. You can see the shift star moved, and what that's doing is actually moving the shift drum inside the transmission. Here you have a spring-loaded bearing, essentially. It's an arm, and what that does is that keeps upward pressures on this, and that helps A, keep it in gear, and B, give it a nice tactile feel. Also had to kick out that random cat because he was getting a little bit much. He kept knocking the camera. He's cool, but I had to kick him out for now. Feel bad, man. I can hear him meowing out there. He wants back in, but I can't have him moving the camera on me like that. Okay, kickstart gear will remove as well. This will just pull out. Once, of course, the spring tension is off. Watch your eyes. Safety squints. Boom. You guys will see on this kickstart gear, there's a spring to spring load this main gear here. And on the back here, you have kind of like a, what would you call it? It's supposed to slip, right? So this here will sit on this part of the engine here. And then what will happen is this is meant to slip. And if you ever heard a Kickstarter go, grrr, that's this part slipping. So this is kind of designed so if the engine's running and this comes into contact, it'll actually slip and not just bind and wreck your leg or your Kickstarter or anything like that. Oh, boom. Oh yeah. That's our shift shaft there. You can see there's a little spring mechanism on here. This part will move freely. I can't quite do it right here, but you can see on this end, there's our splines where our actual shifter would connect. So this is down, first gear, second, third, fourth, fifth. All right, so we've got that side of the engine torn down pretty much as we can go right now. That's the inner clutch side. Now what we're gonna be doing is pulling off the stator cover, and I will go over the components inside the stator cover. A couple bolts, and this cover will pop right off. There will be a gasket in there. So right off the bat, what do we see? Well, this here, this round circle thing, this is what you call your flywheel. Now this serves a couple purposes. One, it adds rotational mass to the engine. So these are actually quite heavy. And another thing is, so if you see where the camera's pointed right now, you see a little indentation, or actually it's coming out on the flywheel. That is the flywheel magnet. And what that does is as this crankshaft is spinning, that flywheel magnet will come around to the pulsar coil here. Now the pulsar coil is basically a Hall effect sensor. So what it does, it senses magnetism. So as that magnet on the flywheel spins around, it'll come across this pickup coil. And the magnetism, it'll actually create a little bit of voltage, and that will send it out through your CDI into your ignition coil, and that's what causes spark. So that's how you get your ignition timing on a two-stroke engine. And you can see on the back of that stator there's actually slotted holes, and you can change that to change your ignition timing on a two-stroke. Generally, you don't need to unless you're in high race applications, but you can normally. So if you were to take this off and you don't put it back where you got it, your bike could be running very strange because the ignition timing is actually off. So these flywheel nuts, I generally recommend taking off with an impact. Makes your life much easier. You need a puller to pull off these flywheels, by the way. You can't get them off. They are pressure fitted to the crankshaft. So you'll need a special tool like the one I've got here to actually remove this flywheel. I just pulled threads. I just 100% pulled threads. Son of a... Super unfortunate news. I was pulling the flywheel off and it pulled the threads out of the flywheel with the tool. That has never happened before. So I'm kind of in a situation right now. What I think I'm gonna do is drill out these two holes in the flywheel, and I'm gonna tap it with a 5/16 tap, run a couple 5/16 bolts in there with a steering wheel puller. So let's go ahead and do that. I've got the holes tapped in the flywheel here, and the goal is to thread these guys in, these two bolts, and this here is a steering wheel puller. Whoa, okay, it went. Geez, it went like now though. And unfortunately, I wrecked the stator. Okay, so this part here is your stator. And what a stator does is, as the flywheel spins around this, it also creates electromagnetic field, and this will actually generate power. So this will supply the CDI, the coil, and everything with the voltage it needs to run. Okay, so we finally got that flywheel and stator off. So now our next step is going to be splitting the cases. So I'm going to go ahead and start getting all these crankcase bolts out. I've got the engine off the stand, and now I've got it on 2 blocks of wood. And I got it on 2 blocks of wood because I'm about to split these cases here. So what I'm going to do is, you can use a case splitter, but I do not have one. So what I'm going to do is tap on these edges with a rubber mallet, and it should start to go. Sometimes these can really fight you, and if it feels like it's not budging at all, double check that you don't have any bolts still in there, because they like to hide bolts in these stator covers, and yeah, you shouldn't have to force it. Got the cases split. And now it's time to dig into the transmission. So if you guys remember that shift drum I was talking about earlier, that is this piece here. And I'm going to pull that out and show you it later. Here we have our transmission. Now these are all our gears, 1st through 5th, including neutral. Here we have our shift forks, which these will slide up and down, moving the gears. When the shift drum turns, these shift forks will move up and down, selecting the gear where the transmission is in. So let me go ahead and get this apart and then show you guys each individual part. This here is the shift fork. As you can see, it has a little dowel here that will go into the shift drum. And then the fork here, one of these rides on a gear, and then this whole assembly moves up and down according to whichever gear you need. Here is the shift drum. Now you can see where that shift star bolted on through here, and then all these grooves that are cut into the shift drum itself, these little indents on the shift forks ride in those grooves. So when you turn this, you can see right now it's at a high spot, and then you drop it down, the shift fork moves low, move it, right now it's pretty much steady, 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 and then high spot here, it jumps up. So that actually is what moves these shift forks up and down, is this shift drum. Another shift fork here, and the third and final one here. Go ahead and pull out the transmission here. So this here is the transmission with all its various gears. So the transmission came out this way, like this, and you can now see this would be our clutch side, and this would be our drive side. So what you can actually see is how these transmission change gears. As you can see right here, see that smooth piece? That's where the shift fork rides. And when that shift drum moves, this will move back and forth, and it'll actually click. So with this one on this side as well, and it'll actually engage. As you can see here, there's some little fingers on there that will engage into the gear on the back side here, if I can get it good in the camera. And when that meshes, that locks that gear into place, and now you have drive. This one is connected to the crankshaft, and this one is connected to the drive. So that's your transmission. It's pretty simple. A lot of people are intimidated by transmissions, but really it's just gears and washers. And if you have a good diagram like on Rocky Mountain ATV, there's really nothing to them. And for our final piece is the crankshaft. Now this is pretty simple. This just has a couple weights on it, a couple crank bearings. These can either stay on the crank or come out with the cases, depending how you do it. We got our crank here. You can see this one is a hot rod, so it's been replaced before. So all this assembly does is rotate. The piston has room to move up and down on it. And this is what basically converts up and down energy into rotational energy. So the crankshaft is a pretty simple thing. You've got to watch out for too much side-to-side play here and too much up and down. You don't want any up and down. You can have a little bit of side-to-side, but no up and down. And for some reason, I thought this crankshaft was seized, but after getting it out of the bike, it actually feels okay. So that is this entire KX250 broken down into detail what every part does. I hope you guys enjoyed this video, and if you learned something from it, let me know. Let me know what you thought about this style of video too, because I didn't really know what to do for the engine teardown besides just make it a time lapse like I said, so I wanted to make something informative for those of you that are trying to learn. Now in the next episode, what we're gonna be doing is building this engine and beautifying everything, making the cases look nice and pretty, and get this thing put together and ready to drop into a frame. Now we still got a long way to go, But I think first step is to get the power plant running on this thing. And I am super excited to build this engine. I think it's gonna look really cool. I didn't see anything absolutely crazy inside. There was a little bit of damage on this one side case from the crank being pushed too far in. And that was definitely part of our issue with the seizing. And I also did notice that the wrist pin from the piston was stuck in the crankshaft. So the crankshaft actually seems okay, but I'm going to replace it anyway because it still has too much play, more play than I would like. So once again, thank you guys very much for watching this episode of the Retro KX250 build, and stay tuned for next episode when we're going to be building this engine. Thank you guys.